All right, today we're cracking open what I like to call the modern data toolbox. We're going to figure out how we store this absolutely incredible, ever-growing mountain of digital information that, let's be honest, powers our entire world. So let's get right into it. Okay, so to get our heads around this whole thing, let's try an analogy. Picture this. All the data in the entire world is one single enormous library. Now, for the longest time, the question of what kind of shelves you should use to store all those books, well, it had a very, very straightforward answer. And that answer? The relational database. I mean, for decades, this was the undisputed king. It was the one-size-fits-all, universal shelving system for pretty much all of the world's most important information. So let's start right there with the old guard. We're talking about an era of structure, of predictability. Basically, a time of perfect order in the world of data. You see, relational databases are all about one thing: enforcing strict structure. Everything, and I mean everything, has to fit into these neat, predefined tables with clean rows and columns. This made them incredibly reliable for the kind of day-to-day operational data that businesses were built on. We're talking sales transactions, customer files, you name it. This is the model that literally built the empires of companies like Oracle, IBM, and Microsoft. But then, well, something happened. A huge disruption. The internet absolutely exploded. And all of a sudden, data wasn't just big. It was big. Like, unimaginably big. So let's go back to our library for a second. It was like millions of new books started arriving every single second. But here's the catch. They were all different shapes and sizes. You had scrolls, videos, audio recordings, billions of social media posts, and they just would not fit on those neat rectangular shelves. The old system just couldn't cope with the sheer volume and, just as importantly, the variety of all this new data. So this massive challenge, it gave rise to a completely new philosophy, a whole new way of thinking about storing data. And it came to be known as NoSQL, which actually stands for not only SQL. And that name is so important because it reveals the core idea here. NoSQL wasn't about replacing the old relational model. Not at all. It was about acknowledging that for these brand new data problems, we needed other models. This was a fundamental shift, and it opened the door to a whole new world of possibilities. This really led to two, let's call them competing philosophies for how you handle data reliability: acid versus base. Now, the traditional relational world, that's all acid. It's all about prioritizing strict consistency and accuracy above everything else. But the new NoSQL world, which was built for the chaos of the web, it championed base, which prioritizes availability and the ability to just scale out massively. So let's break that down. The traditional database world runs on what's called ACID. Think of these as a set of bulletproof guarantees that make sure a transaction, like, say, a bank transfer, is processed with absolute 100% reliability. It either happens perfectly or it doesn't happen at all. There is no in-between. And for things like your bank account, that's kind of essential, right? NoSQL systems, on the other hand, were designed for these huge, sprawling networks, so they often use base instead. This model basically says, look, the data is basically available, and it will become consistent eventually. See, it prioritizes keeping the system up and running over making sure every single computer in the network is perfectly in sync at every single millisecond. And that trade-off, that's the secret sauce that allows for such incredible scale. Okay, so if NoSQL is our new toolbox, what are the actual tools inside? Well, it turns out there isn't just one type of NoSQL database. Nope, there's a whole family of them, and each one is designed for a very specific job. We're going to break down the four main types that you're most likely to run into: key value stores, document databases, columnar databases, and graph databases. Let's meet the family. All right, first up, we have the key value store. This is the simplest of the bunch. And honestly, it works exactly like it sounds. You have a unique key that points to a value. And that value, it can be literally anything, a single word like blue or a whole paragraph of text. The best way to think about it is like a giant, super fast, and super flexible digital dictionary. This makes it the absolute go-to for things like high-speed caching, where you just need to grab a piece of data back instantly. Next up, we've got document databases. These guys store information in these flexible, self-contained documents. Think something like a JSON file. A perfect example is a patient's healthcare report, right? Every patient's file is going to be different with different tests, different notes. There's no rigid structure. A document database handles that kind of semi-structured data perfectly, which is why it's a huge favorite for things like content management systems or user profiles. And the big name you'll always hear in this space is MongoDB. Okay, now this is where things get really clever. Columnar databases. They flip the whole traditional model right on its head. Instead of storing data row by row, like in a spreadsheet, they store it in columns. Now, why on earth does that matter? Well, imagine you need to analyze just one piece of information, let's say total sales, across billions of records. A columnar database only has to read that one single column and can ignore everything else. This makes it unbelievably fast for huge-scale analytics and data warehousing. Cassandra is a major player here, built for exactly this kind of heavy lifting. And finally, we have graph databases. These are purpose-built for one thing: understanding relationships. It's all about the connections. They use nodes for the things themselves, like people or products, and edges for the lines connecting them. This makes them the perfect and really the only choice for things like social networks, fraud detection, or complex supply chains, basically anywhere the connections are the most important part of the story. Neo4j is a big leader in this space. So, when you look at the whole toolbox like this, the key takeaway is all about the trade-offs. You can really see how each tool is highly specialized. For pure, raw speed and scale with simple data, you grab a key value store. For massive analytics, it's got to be a columnar database. But if you need to map out really complex relationships, then the graph database, even with its added complexity, is truly the only tool for that job. So, after all this disruption and all this innovation, where did we actually end up? Was it some epic battle between the old guard and the new kids on the block? Not exactly. The reality is, well, it's a lot more collaborative. You see, it was never really a SQL versus NoSQL fight. It was never a zero-sum game. The real conclusion here wasn't about which database was better, but the simple recognition that the modern world needs both. It's SQL and NoSQL. And that right there is the modern solution. Companies today still rely on those ultra-reliable relational databases for their core business data, the stuff that absolutely cannot be wrong. But for all the new, massive, messy data, they pull out the specialized NoSQL tools. By combining the strength of both, they get the best of both worlds and create these incredibly powerful, flexible, next-generation solutions. And you know what? The story doesn't even end there. This toolbox is always expanding. There are even more specialized databases out there, like spatial databases, which are designed specifically to handle geographic information. Seriously, every single time you use the GPS on your phone, you are tapping into the power of one of these super specialized tools. And this brings us to a final thought. This whole evolution of how we store data is driven by one thing: the problems we need to solve. As our world keeps generating new types of data and brand new challenges, that toolbox is just going to keep on growing. Which leaves us with a pretty cool question to think about. What problem will the next database be built to solve?